we present a prototype VR user interface for robot teleoperation that supports high-level goal specification in remote assembly tasks. The user asynchronously assigns multiple goals in the form of 6 DOF destination poses by interacting with virtual replicas of task objects. Existing work on asynchronous high-level goal-based teleoperation has predominantly concentrated on control methods for robot teleoperation. In contrast, we describe and compare different visualizations for monitoring and managing these assembly goals in headset VR. Our user interface employs 2 different spatiotemporal visualizations for assigned goals. The aggregated view represents all goals within the user's workspace, while the timeline view depicts each goal within a separate world in miniature. We have 2 variants of aggregated view: static aggregated view and adaptive aggregated view. The static aggregated view is an aggregated view in which the user sees each object in its goal pose and previous pose. The adaptive aggregated view introduces adaptive filtering features to the static aggregated view. In its default state, with the user not touching any object, the interface displays each goal pose and previous pose, just like the static aggregated view. However, when the user touches a goal pose or a previous pose, non-essential information is filtered out. The timeline view presents a timeline of worlds in miniature, where each world in miniature represents a specific goal. By default, the user sees the scene with the goal poses of every object, and they can assign new goals by grabbing and manipulating them. The user can point to a world in miniature and select it to update the main scene so they can check the status of the selected goal. We conducted a user study to compare how these visualizations affect user efficiency and task load. The results show that while the aggregated view helped the participants finish the task faster, the participants preferred the timeline view. We also implemented a prototype with a physical UR5 robot arm equipped with a parallel gripper to demonstrate that our system works with a real robot. To learn more, please see our paper.